Okay, welcome all, and thank you for joining today's AWRI webinar. My name is Michael Downey, and in this session we examine climate drivers and outlooks and what they mean for Australian wine grape growing sector. But before we make a start, a couple of quick reminders for anyone that's new to AWRI webinars. To provide a comment or to ask a question, please open the Q&A section of your toolbar or your Zoom toolbar. Type your question in and click to send it through. Also a reminder that this webinar is being recorded and it will be available to view later via the AWRI's YouTube channel. Now, for those of you that have just joined, welcome. Today's webinar topic is climate outlooks. Now, we've had a late change with regard to speakers and Paul Lainio will be stepping in for Dr. Naomi Benja, who was unfortunately not able to be here today. Paul is a meteorologist at the Bureau of Meteorology and has worked closely with the wine sector to support them in making sound business decisions. Paul Lainio, it's great to have you on board. We have another Paul with us today, Dr. Paul Petrie, who's a regular contributor to AWRI webinars, and the principal scientist for viticulture and manager of the irrigated crops at Sardi. Paul leads a viticultural research program aiming to improve the resilience of Australian vineyards, including developing strategies to better manage dry winters and to understand and better manage vintage compression. So terrific to have both Paul Petrie and Paul Lainio with us today. Paul Lainio, if you're ready to make a start, I'll get you to start sharing your presentation file and take it away.
Okay, I think we're probably off and running. Give us a thumbs up if that's all right. Yep, nod happening. So yeah, all good. And I'm a late replacement for Naomi. Naomi's done all the hard work, so I'd like to thank her for that. And hopefully you'll see some of what we have experienced over the last year or two, and also a look into the future. And I'll try and highlight some of those aspects of the weather which might be more important to the wine industry. So I'll just move ahead. We have a quick summary here, so we will revisit this slide toward the end, and I guess I'm glancing off to the side. I've got another screen here, so I apologise for that. But perhaps the aspects of the season ahead which are of more relevance might be heat wave. We'll talk a little bit about what we can expect in terms of heat waves in the coming season ahead, and also we may perhaps be a little bit interested, not so much in the widespread flooding, but the rain expectation as we move into the season ahead. So we'll have a look first at what has happened. So we came into 2020 with, I guess, conditions really quite dry, and we've ended up in a La Nina scenario where we're expecting, in a general sense, more rainfall than you would normally expect. And you can see we're beginning to show La Nina type rainfall patterns here on the January to October rainfall. So it's a long period, not all of which was La Nina, but now we're beginning to see above average rainfall for that period in January, October through the southeastern part of Australia. Much of Australia experiencing above normal temperatures, highlighted in the yellow there. So it's been for parts of Australia a little bit wetter than normal, and certainly if you look at southwest WA, drier and warmer than normal. So if we look in a shorter period, August to October, that the impact of La Nina has a stronger influence, and the wetter conditions across larger parts of Australia and continuing dry in southwest Western Australia, also across the western parts of Tasmania. And where it's raining, generally, is a little bit harder to get hotter. So for that longer period, or for that period August to October, just generally average conditions, but certainly as we're experiencing in South Australia right at the moment, there have been some hot days within that. And whenever we're talking of a climate type forecast, we need to bear in mind that the weather is different to climate, so we still might have incredibly wet days, incredibly hot days, but the climate forecast might be for a more general description of what we expect. Within that, the weather changes on a daily basis. So yeah, some areas receive significantly higher falls than they may normally. If we look at South Australia, for instance, 68% above average, the 10th wettest on record. But when you look a little bit more closely at those areas, largely they weren't the wine producing regions of South Australia. So just over the last, or the month before now, we saw October continue to be really quite wet, but we've had the tap turn off, in fact, for the latter part of October and November. And the repetition of the similar pattern, drier in Western Australia, drier west coast of Tasmania, and where it was wetter, we see those temperatures more like average, or in fact some even a little bit below average. So rainfall deficiencies, if we look at the 6-month period, we see Western Australia largely stands out as drier than normal. I guess not quite as evident through those Margaret River type areas where some grapes are grown, but certainly up into the Swan Valley, it's been drier than normal through the 6 months. Through the April to September period, 2018 to 2020, we see long-term rainfall deficiencies remain across Australia. So when we look on a year-to-year basis, yeah, the rains really haven't been coming. And it's only this year that we're seeing a bit of a catch-up through the Murray-Darling Basin, the southeastern parts of Australia. This has affected root zone soil moisture, so I guess the area of the soil where the plants can access the moisture. So we see large parts of South Australia, not wine growing districts, but extending into New South Wales, certainly in parts of Victoria, where earlier on September, October, there were actually some flood warnings out through the Ovens Valley and so on. So there were some really quite intense falls, and we can see in general the Lainio influence is also impacting on the soil moistures across Australia. If we look back at some of the more recent years, so 2019, very dry soil moistures in the same period. 2016, we see really quite wet, and in the 2016 year, we see negative IOD, which is positive for rainfall, so helps to get those northwest cloud bands developing and moving across Australia. So as far as water storage goes, we can see Tasmania 57.4, so really needing to see a few more good rainfall events to boost the water up. And in fact, now that we have moved into warmer months, the soils are a bit drier, so it'll take a little bit more to get those runoffs happening and flows into the rivers. The Murray-Darling Basin itself, 69%, and up in the north, although there have been a couple of rainfall events over the winter-spring period, that's not really the time at which we expect the big inflows into those areas. So that's currently the status, I guess, of water across South Australia, at least some areas anyway. So climate influence, as we've heard, probably given you're in the agricultural industry, you would have heard week after week after week talk about La Nina developing, and then the announcement that we have reached the levels at which we do declare a La Nina. So for a while, it was looking as if those conditions were coming, and then we did reach those levels. So we look at the water temperatures across the central Pacific, I guess, and if we see the waters cooling there, but warming closer to Australia, what we end up is a little bit like a boiling pot of water. So air rising and moisture rising near Australia, and that is why the La Nina pattern is more conducive to rainfall, because we have a better moisture source, and we also get trade winds bringing the moisture into Australia. We also see some other impacts, like the southern annular mode tends to make it more likely that we see easterly winds across the lower half of Australia, and again that helps to bring the moisture into Australia. Low pressure troughs within that area help to lift the moisture, turn it into rainfall. So what we have this current pattern is certainly La Nina is active in the Pacific. So likely to be moderate to strong and persist for quite a while. So right through till February, maybe even March 2021. So if we look at the graph on this side, that basically tells us when we're below this 0.8 line, the indice here, and we then remain below that right through until March, April, that indicates we're in La Nina conditions, and the spread is basically our ensemble model of what could happen. So most of the ensemble indicates we're staying in La Nina for a fair period. When we have our wettest years, we often have a positive Indian Ocean dipole as well. The Indian Ocean dipole in this case is neutral and expected to remain neutral. So the La Nina is operating in isolation from the Indian Ocean dipole this time. Southern annular mode is positive, and that in winter can mean less rainfall, but when we're combining it with La Nina in summer, it can actually tend to help the rainfall across Australia. And just against the long-term trends, all of these comments should be borne in mind against the long-term trends. So 10 to 20% decline in southern Australian cool season rainfall. So getting harder and harder to see the soils wet up during the winter. And also on top of that, just a general warming trend. Certainly we notice that most in summer, but it also is evident in winter. So if we compare previous La Nina events versus the current La Nina event, so what we see, I've mentioned already, moderate to strong until at least February. This one was not as strong as La Nina at this point. So the 2010 event was a stronger event at this time, and also the Indian Ocean, as I mentioned, did provide additional reinforcement for that the rainfall across Australia. So now we move into what we do expect. So our climate models are run, and they take into account dynamically the impacts of the ocean and the climate drivers. So we see for maximum temperature, and in fact, if we look or comment briefly about maximum and minimum temperature forecasts, these chance of exceeding the median are have to be borne in mind with respect of climate change. So we have had a warming atmosphere, and very often this red that you see on the charts here is on every chart, no matter the climate driver. So La Nina is having an impact here in that the reds are not as red, and in fact there's some areas where we have a higher rainfall expectation where we're heading toward average type temperatures. So maximum temperature in general, warmer than normal for large parts of South Australia and Victoria, more normal in New South Wales, and still around the southwest of WA, warmer than normal. Overnight minimums certainly remaining really quite warm right throughout, and I guess you can imagine hot days probably lead to hot nights. Cloudy days also lead to hot nights. So if we're expecting, as the chart on the right says, more rainfall likely across Australia, then a fair bit of cloud, or more cloud than we would normally expect. So this is for December, and we can see the impact of La Nina. In fact, every year is different, every La Nina is different, but currently we're showing quite an impact across much of Australia as far as rainfall is concerned. In some areas, the amount of summer rainfall for South Australia, for instance, we don't expect a lot of summer rainfall, so 1 or 2 rainfall events of 10 to 20 millimetres perhaps might push us over that median rainfall expectation. If we look at the December to February, so the seasonal type outlook, similar picture. So not surprisingly, we're still under the La Nina influence, a little bit more marked with cooler than normal temperatures through the New South Wales region, and certainly marked in respect of the western parts of Tasmania, drier than normal. The impact for other parts of Australia, not so evident. For instance, southwest Western Australia is not really, it's certainly not showing up as an expectation of drier than normal conditions. And then if we push forward a little bit further, so the same seasonal outlook, we perhaps begin to see a little bit of an easing in La Nina. We don't have those cooler temperatures quite so evident through to the March period, but the pattern is broadly speaking the same: above average rainfall, warm nights, and parts of Australia experiencing warmer than normal conditions. As far as heat waves go, the long-term trend of extreme heat, not necessarily heat waves, but the long-term trend of extreme heat is rising, as we would expect under a warming atmosphere scenario. For La Nina years, we do still expect heat waves. Every Australian summer, I guess, has heat waves, but in La Nina years, we don't really expect those heat waves to be as extreme. So instead of getting up to the low to mid 40s, perhaps, it might be a bit lower, but those heat waves might last a little bit longer and be a little bit more humid. So that's important to bear in mind. We're not saying there won't be heat waves. In fact, they may be really quite long-lived. So just summarising, we are in La Nina, so higher than normal rainfall expectation with a long-term deficiency still evident. The southern annular mode is currently strongly positive, so will remain so for the rest of 2020, and that will help to enhance rainfall. So high chance of above average rainfall combined with a bit of humidity. I guess in the wine industry, you need to keep aware of that risk, because that will raise some of those pesticide, fungicide type issues that you may have. So that's yeah, the summary of or the end of my talk. So I'll hand it back.
Okay, fantastic. Thanks very much, Paul Lainio. We're going to move from here into a presentation, or a quick presentation from Paul Petrie. So Paul's going to provide a bit of a viticulturist perspective regarding what Paul Lainio has already spoken about. Paul, if you're ready to go, I'll hand it over to you to take it away.
Thanks, Michael, and thank you to Paul Lainio as well. So just to, I suppose, give us a bit of context with the, when the BOM announced that we were moving into the La Nina cycle, a lot of us in the industry remembered the last La Nina we had in 2011, and they weren't necessarily good memories. We certainly started to get some more inquiries here at SARDI, my colleagues in the pathology group, around how to manage those sort of wetter conditions, and also my former colleagues on the in industry development and support at AWRI likewise started to receive more of those sort of questions around, oh cripes, you know, if we're going to have a really wet spring, a wet summer, you know, what's that going to do for our vintage? I suppose in response to that, a couple of my other colleagues at SARDI, Dane Thomas and Peter Heyman, looked back at previous La Ninas to say, okay, you know, we have this as a forecast. You know, where are we expecting? Is it really going to look like 2011, or might it just be a more average season, or a slightly wetter than average season? So they basically just went through, if we're going on slides, and looked at the rainfall across the last 120 years. They then ranked those from the lowest to the highest rainfall, and then they divided them into deciles. So a decile is basically just dividing them into 12. The highest, the 10th decile is the 12 years with the most rain, and the first decile is the 12 years with the least rain. And then they're all nicely color coded in shades of red and orange and blue. Blue obviously being wet, and red being dry, and even then wetter sort of with that sort of shading type, hashing type pattern on there. So once you've done that, you can then start and look and say, okay, how do these deciles relate to the season? So we'll put them back in order again from 1900, and then we can mark on those the 30 years since 1900 that we've seen a La Nina event. So those X's are a little bit small, so I'll make that a little bit bigger. So I mean, the first thing that sort of struck me when I'm looking at these, okay, we have some very wet La Nina years. We've got the 2011 vintage here that we all especially remember, but we also have some drier La Nina years. We're going back with down here, and these ones earlier in the century, and even 1998. Where we've had sort of average or below average rainfall, although it's been La Nina. So I suppose the first thing to emphasize is while La Nina certainly increases the chances of rainfall, it doesn't guarantee that we're going to have a wet season. Next question is, okay, what does it do for those chances? If we look back at history, when we've had a La Nina event, what has that done to our rainfall? So if the chance of rain is the same, or the decile distribution is the same every season, then all the bars are all the same heights, and all the little segments in our pie graph are all the same size. So that's across all the 120 years. If we look at how those are distributed across the 30 La Nina years, we can see that, okay, there are more up at this end, the wetter end, but we also have some down at the dry end. And if we turn that into the pie graph, because the pie graph's easy to display more than anything, we can see, okay, so that coming up, half of those seasons were quite wet, but there are still some of these dry ones. The beauty of doing the pie graphs is that we can then impose those on a map of Australia, and you can basically have a look for your region and say, okay, what does it do for what does the forecast of La Nina likely do to the rainfall pattern in my region? And we can see that some of those, obviously the chances of that higher than the median rainfall are increased, but there is still a chance that it will be dry as well. So this is October to December rainfall, and then moving through into the summer period. Likewise, that chance of rainfall remains, or higher than median rainfall remains in place. So probably what's more, more critical, or what's more interesting, what can we do about it? What do we expect? As Paul Lainio pointed out, the more humid, moist conditions are conducive to disease. This is an analysis that we did when I was at the AWRI. We did looking at the impact of evapotranspiration on the amount of fungicides or fungicides applied to manage powdery mildew. So evapotranspiration is an estimate of water use. So for grapevine water use, we use it for irrigation scheduling, but it can be used for an estimate of pasture water use or anything like that. And what is good about it is that it consolidates not only rain, but also the humidity, the wind speed, the solar radiation, a lot of things that work together to drive disease. And what it said was that when we looked at it, these are average, each of those dots is a season and a region combination. So there's 3 regions in here. There's Langhorne Creek, Coonawarra, and the Barossa, that when we had dry conditions, so higher evapotranspiration, we saw less fungicides used. And when we had wetter conditions, i.e. more evapotranspiration, we saw more fungicides applied. While these are for October, November figures, obviously we're not at the end of November yet, but when I did a quick tally up looking at some of the evapotranspiration figures we've seen today, we are certainly sitting up at this end of the graph as opposed to this end of the graph. So we're confident that the disease pressure is high, and we need to be responding to that. So pretty simple viticulture pathology type messages. We're likely to have more downy mildew events, and most of us are fairly familiar with how they work. The classic 10-10-24 model, where we see more rainfall, warmer temperatures, we're likely to have downy mildew problems. Likewise, we have higher powdery mildew pressure from the graph that I showed previously. How are we managing these? We want to ensure that our sprayers are well set up. Marcel Essling on the help desk at the AWRI last year and the year before ran a series of workshops on sprayer calibration and setup. He's still got all the material available for those. So if you need any tips, I'll go and go back and refer to him through the help desk. Next step, you want to ensure that you've got enough chemical available. once again, we're not looking like we're going to be in a 2011 season, but it pays to be safe. Certainly, there's always the worry about metalaxyl. Once again, I touched base with Marcel, and he said, look, that we're not seeing any shortages at the moment. There's no plans to apply for special use permits or anything like that. Everything should be okay, but yeah, you want to be aware. The last one I've got there is botrytis sprays. So I know it's certainly not all the industry apply botrytis sprays as a standard every year, and even with these conditions, I'm sure there's a good portion of the industry that effectively don't see botrytis sprays as their part of their program. I suppose who this message for really is for growers that would put botrytis sprays on in some years, but maybe not put them on in other seasons. Now would be this would be a good season. Or if you have blocks that you have historically had problems with high botrytis pressure, this would be a good season to consider applying those sprays. There are growing restrictions on withholding periods and the amount of chemistry that's available, but there are still options available for most of you if you aren't at peppercorn stage yet for your berry development. There are botrytis options available if you're in that category. So in conclusion, say I've just got a cameo role here today. La Nina increases the chance of having a wet summer, but it certainly doesn't guarantee it's going to be like 2011. Watch your pest and disease. So I say more scouting, manage your sprayer set up, just be extra vigilant because the pressure is certainly higher. The worst thing you can do is come back from your Christmas break and discover this powdery mildew all through your block. It's once you get to that stage, it's very, very difficult to control. Passing the baton back to Paul at the Bureau of Meteorology again, they will have really good short and medium term forecasts coming out. Follow those forecasts because they're really useful as part of your planning. Thank you very much, Michael.
Okay, great. Thanks very much, Paul Petrie. From here, we're going to roll into a Q&A period. So both Paul Petrie and Paul Lainio will stick around for a little while to address any questions you may have regarding their presentations. So please do take this opportunity to send through your questions. Just a reminder, if you do want to ask a question, click on the Q&A button in your Zoom toolbar, type your question in and click to send it through. We've had one question come in through already. And this one's probably for you, Paul Lainio. The question is, what temperature or degree rather is considered extreme?
So that was in reference to the graph which showed basically year by year we're seeing more temperature extremes. So what that graph is showing is we look at both the maximum and minimum, so we get an average for the day in a way. And we look at conditions over the 1910 to 2017 period. And we look at the aerial average for Australia. So we have an algorithm basically which takes all our temperature observations and is able to average them across Australia. Then the extremes are the top 1% of those measurements. So we're seeing, in fact, in the early part of the 20th century, really we weren't seeing days of that top 1% of temperature extremes. And as you head toward the current period, each year has numerous days of these top 1% temperatures. So that's the extreme we're talking about, the top 1% of aerial average temperatures across Australia.
Okay, thanks, Paul. We do have a bit of echoing coming through from your end. Is it possible you've got a second device or speaker running at the moment? Because certainly earlier we weren't getting that issue. I'm
just going to unplug and, in fact, I might even just try unplugging my headphones, and talk, to, the
Sure.
Is this any better?
We'll push on and see how it goes, Paul. Certainly, we could still understand you, but there was a little bit of echoing, so hopefully that's resolved the issue. We've also got a question here about whether the Bureau have a heatwave occurrence forecast model.
So heat waves, when we look at heat waves, 1 day of hot weather is not a problem, especially if there's a cool night. We look at heat waves in terms of human health effectively. So a 3-day period where the maximum and minimum is unusual for a location, so it is adjusted per location. Where that is satisfied, then we can call it a heat wave, and we have different levels. So how unusual, as we head up into that top ranked heat, then we can have severe or extreme. So we do have a model that we use whether or not we are expecting heat waves, and currently there's a large area of severe, some heading into an extreme heat wave moving across Australia. Toward next week, we expect cooler conditions to push across certainly the southern part of Australia and eventually move into the southeast Queensland area, which is also expecting to get heat wave conditions.
Okay, thanks, Paul. Question here about cyclone activity and whether we can expect increased activity around that for the upcoming season.
So in La Nina years, yes, generally we do expect higher numbers of cyclones. So that is the case this year. And we also expect the monsoon to come a little bit earlier, so we may get earlier cyclone activity than we would certainly in an El Nino year.
Yep. Okay, thanks, Paul. Paul Petrie, might direct this one your way. Question here from Sue. The increasing heat wave incidence seems to be impacting on UDIBA becoming worse in the Clare Valley region and the need for increased irrigation. Are you aware of any research regarding how to reduce UDIBA and manage in accordance with the future climate expectations? The expected rainfall in Clare does not seem to be that high despite La Nina.
So I suppose UDIBA management isn't my area of expertise, but my colleague at SARDI, Mark Sosnowski, obviously works extensively in this area. I was having a chat about this with him the other week, and he's been running some trials where he has, so this is in the Riverland, he's reduced the irrigation supply to a vineyard or patches in a vineyard, to look and see how that impacts on the UDIBA incidence. Somewhat surprisingly, the reduction in irrigation didn't appear to increase the amount of UDIBA that was there. I think he was expecting that the more water stressed vines would have more UDIBA present, but he didn't see that. So beyond that comment, I'm sorry I can't really help a lot with the question, but I'm sure. Maybe if you contacted the help desk or you contact me later, we can put you in touch with Mark to answer that question in more detail.
Yeah, absolutely. Thanks for your question there, Sue. Also a comment more than a question about the fact that there hasn't been a lot of frost or frost risk in this season. Do either Paul Lainio or Paul Petrie have any comments around that one?
I was just reading a question, so I was tuning out a little bit. Apologies for that.
And Paul Lainio, I think it was probably better without the headset on, to be sadly. Paul Petrie, did you want to jump in on that one?
I mean, I think as Paul Lainio commented, due to the La Nina, we see a bit more rainfall and we have more cloud cover. And both of those are likely to reduce the frost risk. So the clouds provide effectively insulation, and so they stop the radiation frosts, and the increased moisture in the soil allows the soil to absorb and retain more heat during the day and then radiate that out during the night. So once again, reduces the frost risk. Paul, as the meteorologist, I'm happy to be corrected on that.
That's perfect.
Okay, thanks very much, Paul Petrie. Question here from Jim about whether there's any record of phenological development, in particular with regard to the Perth region, and whether this development is advancing. So, for example, Jim mentions in the Swan Valley we had record rain in the first half of November, and we harvested about 2 weeks earlier last year. So I guess this is a question about vintage compression, Paul. Petrie,
maybe more vintage advancement than compression, but I can certainly answer this one. So when we've been tracking phenology across all Australian regions, and this is especially phenology as it relates to when you harvest as opposed to the bud burst and flowering and things, we've been seeing it come earlier at virtually all sites. I haven't seen figures specific to the Swan Valley, but I don't see why your trends would be any different to the rest of the country. Generally, since the early 90s, it's been advancing at somewhere between 1 and 2 days per year. So now, coming up a month earlier than it may have been 20 or 30 years ago. Certainly there's a lot of old well-established wineries in the Swan Valley, and you may be able to find someone with some nice harvest records that you can go back through and sort of confirm that trend. But I would be surprised if that wasn't the case. When we've tried to relate weather events or climate events to that changing phenology, generally we've seen more of an impact of temperature than we have of rainfall. I think that's mostly because the temperature trends have been more consistent than the rainfall trends. So I'm not saying that rainfall hasn't had an impact, but rainfall is much more variable and has generally changed less than what we've seen for temperature.
Okay, fantastic. Thanks very much, Paul. And thanks for your question, Jim. We don't have any further questions at this stage, so I think we might begin to wrap up. Do either Paul Lainio or Paul Petrie want to make any final comments before we do so?
All good, all good,
yeah,
all good.
Thank you very much.
Sure thing. So before we do start to wrap up, I'd just quickly like to draw your attention to a resource that's available via the Wine Australia website. It's called the Wine Atlas, and this tool will help you answer the question, a very important question, what will my region's climate look like in the future? So if you haven't already had a look at this tool, I strongly suggest you get on the Wine Australia website and take a look. And if you've got any questions about how it works, please do contact Wine Australia for further information. Okay, so I'd like to just finally wrap up by thanking both Paul Lainio and Paul Petrie for coming in and presenting and sharing some really important information and tools for the audience to be aware of regarding the upcoming season. I'd also like to thank the audience for being involved in today's webinar. A reminder that you will receive a follow-up email with a link to the recording of this session, so please look out for that. There'll also be a survey there, so if you feel like, we do appreciate you filling in that survey also. Acknowledgements to Wine Australia for providing funding and support for AWRI webinars via the AWRI Extension Project. The next AWRI webinar is next Thursday, 3rd of December. The AWRI's Dr. Eric Wilkes takes an in-depth look at measuring Beaumet and bricks and understanding their relationship with phenol alcohol. If you haven't registered for that session and would like to do so, please visit the AWRI website. That's all we have for today. Thank you again for logging in, and I look forward to seeing you at the next AWRI webinar.